All right, so in section 8.8, we introduced graphing root functions. In this section, we're going to make just a few more changes to the basic parent functions. We're going to start off here by regraphing the square root function. So just a reminder that you get to pick your x values, but you want to pick the values that make your problem easy. So numbers that you can take the square root of nicely. So for my table, I'm just going to go ahead and use let's go 0, 1, 4. And if you want, you can add 9. You certainly don't have to. And then you take the square root of each of those. You get 0, 1, 2, and 3. If you plot those points, we're looking at a graph kind of like this. And as we said yesterday, because you can't take the square root of negative numbers without introducing imaginary solutions, we only have an arrow going one direction. Our domain then, x is going to be greater than or equal to 0, because if we plug in negative numbers and we introduce those imaginary solutions, and our range is also greater than or equal to 0, because if you look, we start here and we only go up forever and ever and ever, never go down. So that is the parent square root function. Similarly, we graph the parent cube root function. So again, we get to pick our x values. And again, you want to make your life easy by picking numbers you can take the cube root of. So yesterday we tried values like -8, 8, 1, -1, and 0, just something like that. If you take the cube root of each of those, we're looking at -2, 2, 1, -1, and still 0. So if I plot those points, -8, -2, 8, oops, that's 9. 8, 2 would just be the same thing, but kind of up here. 1, 1, -1, -1, and 0, 0. Because you can plug in some negative numbers, we have arrows going both directions here, left and right. So our domain is all real numbers, and again, because it's an odd indexed radical, it's always going to be all real numbers. Doesn't matter what else I add to this, it's always going to be all real numbers. My range is going to be the exact same thing because, again, my graph is going up and down forever. So in the next example, it says, how can I obtain the graph of y equals the cube root of x minus 2 plus 1 from the graph of y equals the cube root of x? So this right here is called the parent function. So we're just talking, making changes to the parent function in order to obtain new graphs. So you'll notice then we have a -2 underneath the radical here, and we also have a +1 outside. Those are the two changes. What we're going to call those values are h and k. And we've graphed like this before with a, h, and k, and what h and k were our shift. So in this case, just like always before, your h value always switches signs. So h is +2, k is +1. K stays the same. So what that does is it shifts. So what's happening here is we have a shift of that point 0, 0. So this point right here on the parent function, we're taking that middle point and we're shifting it to the point 2, 1, and everything else we'll graph the exact same. So, excuse me, I'm going to start by plotting that point, 2, 1. As soon as I get there, there we go. So I'm going to start by plotting that point, 2, 1. Okay, now we're going to make our XY table exactly how we did before. I'm not going to change a thing. And I don't have an A value up front, so I don't need the AY column. Oops. I'm going to pick those same 5 values. -8, 8, -1, 1, and 0. And then if I take the cube root, we're looking at -2, 2, -1, 1, and 0. But now the trick is you're not plotting from the origin. I don't have a point right here to plot from anymore. I'm actually going to plot from that point HK. And if you want, you can kind of draw in your new x and y axis, because that's kind of what we're doing. We're shifting the origin here. So we're plotting points right from there. So the first point, -8, -2, will be somewhere down here. If you count 8 to the left and 2 down from that center point, that's where you'll end up. If you plot the point 8, 2, we're looking at something right up here. -1, -1, +1, +1, and there we go. So that's how we're going to graph these functions today when we're going to add a number underneath the radical, that's h, and a number behind the radical, that's k. So here we go. It says graph, and then state the domain and range of the function. So I'm going to start by identifying hk. So h is underneath the radical, switch the sign, so it's +3. K is behind our radical, keep the sign the same, so we're looking at the point 3, 2. So that's my new center. That's where I'm graphing everything from. I'm going to make my table the exact same way, so x, y, and now because I have an a value out front, I do need that third column, a times y. I'm going to pick the same x values because what happens is when you plot that shift, what's going on is we're basically saying, okay, we shifted it, this stuff doesn't exist anymore, so we're just graphing what we called earlier the parent function. The cube root of x is what we're graphing, and then the 2 is taken care of in this last column here, -2. So we're going to plug in -8, 8, -1, 1, and 0. If I take the cube root of each of those, this is what I end up with. But now, because I have an a value, I have to take a times those 5 numbers I just wrote down. So -2 times -2 is +4. 2 times -2 is -4. -1 times -2 is +2. This is -2, and 0 times anything is 0. Excuse me. As I mentioned yesterday, if you have an a value, you find your last column, you can cross out the middle column because it's no longer good to us anymore. And we're plotting x and ay, those two columns, from our shifted point right here. So the first one, -8, -8, +4, is up here. And then 8, -4, this one might jump off our graph. Somewhere down here, not by much though. -1, 2, +1, -2, and then our 0, 0 point is our shifted point right here. So you actually don't need to plot that point again. So here's our graph. And as we discussed, h and k, they shift that middle point. This point right here, they shifted our middle point over to 3, 2. The 2 out front makes our graph taller than the parent function. If I were to scroll back up here, here's the parent function. It's not quite that tall. And then the negative kind of flips it upside down. So that is how we're going to graph. Now the last thing we need to talk about is domain and range. So domain, these are the values you can plug in. And once again, because we're dealing with an odd indexed radical, it doesn't matter what else is underneath the radical. It's always all real numbers. Same thing with my range. Because it's an odd index, it's the cube root, not the square root, I can have all real numbers. There are no limitations. Okay, excuse me. So we're going to graph a square root function the exact same way. We're going to start by identifying h and k. Here's h, here's k. We're going to plot that point first. Oh my, won't it let me write? Okay. Right here. Then we're going to make our xy table, xy, ay, because I do have this a value up front. And then we're going to pick our values that we can take the square root of, because again, when we plot that shifted point, we can forget that this stuff exists and it's just the square root of x again. Now I'll need that here in a little bit, so I'm actually not going to leave it scribbled out. But we want to take the square root of nice numbers, so 0, 1, 4, 9 are probably your best options. Take the square root of those, you get 0, 1, 2, and 3. And that last column says take a, well here's a, times those y values, so we are looking at 0, -2, -4, -6. So cross out that middle column, don't need it anymore, and plot the other point. So 0, 0 again is your shifted point. You actually don't need to replot it. 1, -2 is right there. Because remember, I'm plotting everything from that shifted point from HK. 1, 2, 3, 4, -4, it's right here. And then 9, so 3, 6, 9, 2, 4, 6. So here's the last point. And you know what the square root function looks like. You know it only has an arrow going one direction, and it's not at the origin point, it's at the other point. So our graph looks something kind of like this. So now we need to talk domain and range. Let's talk range first, actually. So at range are the y values. So you can see we're starting here, and my graph is going down and to the right forever. So it's only going down. So my range then is going to be less than or equal to, because my graph's going down, and then whatever number we're at right here. So it looks like 5, which a little note for you is always your k value with a square root function. So less than or equal to 5. My domain then, if you want to look at your graph, let's see if I can get rid of some of this here. If you look at your graph, now we're going to the right, so we're going to say that x is greater than or equal to, and then whatever value this is right here, and it looks to be -3. Now, and it is, the algebraic way that you can get there is to take whatever's underneath your radical, x plus 3, and we've said this before, but x plus 3 has to be greater than or equal to 0, because if it's not, you get negative numbers, and then you're taking the square root of negative numbers, which introduces imaginary, which we don't want. And if you solve this, you get your domain anyway. And again, these are only with square root functions. The index here is 2. If it was an odd number, if it was a 3, a cube root, it wouldn't matter. It's always all real numbers. You're only really looking out for the square root functions. So let's do one more of those, and then I'll call it good here for this video. So we're graphing this square root function again, state the domain or range of the function. So first of all, let's identify h and k. Here's h, -4. Here's k, -1. Because remember, you're switching the sign of h, but k stays the same. So I'm going to plot that point first. And now we're graphing everything from there. Now, I need to make my xy table. And actually have an a value, so I need the ay column as well. And we're picking points I can take the square root of, so why not 0, 1, 4, 9 again? Take the square root of those, 0, 1, 2, 3. And the last part says take a times those numbers you just wrote down, 0, 2, 4, and 6. Don't need this anymore, done with it. So 0, 0 once again is your shifted point, no matter what graph it is, so you don't need to plot it. 1, 2. There we go. 4, 4. 1, 2, 3, 4. Right about there. And then 9, 6. It's right about there. And again, it's a square root function. Has an arrow only going one direction. So something like that. So what changed here was we shifted that point 0, 0. We went to the left 4. And then we went down 1. And then that 2, my a value 2, kind of made my square root function graph taller. So the last thing we need to do here is domain and range. So again, I'm going to start with a range, and I told you in the last example with square root functions, your range always comes from k. So my k value is -1. So why is something compared to -1? So you just have to decide, is it greater than or equal to or less than or equal to? And if you look at your graph, my graph is only going up, so it's going to be, going to be greater than or equal to the x values. You can also use your graph. But remember, whatever's underneath our radical, in this case x plus 4, has to be greater than or equal to 0 to avoid imaginary numbers. So if I subtract 4 from both sides, we're looking at x is greater than or equal to -4. And like I said before, that is also your k value, or your h value, sorry. That comes from h, that comes from k. You can also see it on your graph, but there it is. That is how you graph shifted root functions. And that is it for section 8.9.